Okay, so in this video we're going to talk about anti-deriving marginals and rates. Alright, so if we have a marginal and we want to go to a total, we take an antiderivative. Let me illustrate this. So if we take a derivative of a revenue function, for example, a total revenue, we'll get marginal revenue. If we want to go back, if we want to go from marginal revenue to this total revenue, we integrate the marginal revenue. This is also true for cost and marginal cost. If we want to go from cost to marginal cost, we differentiate or take the derivative. And if we want to go from marginal cost to the total cost, we antiderive. This is true for rates also. So if I have the rate of change of a average cost function, and this is represented by the derivative of c bar, we can go from that rate to the original average cost using an integral. All right, so let's do a few examples illustrating this principle. So suppose we have a marginal revenue of 1 over the square root of 0.5x plus 4, all plus 2.8. And we want to find r of x, the total revenue, given there is no initial revenue. i.e. r of 0 is 0. All right, so let's do an antiderivative. So like I said earlier, to find revenue from marginal revenue, we're going to integrate this marginal revenue function. If we integrate the first part, we're going to have to use a u substitution. And if we integrate the second part, the integral of 2.8, the antiderivative of 2.8 is 2.8x plus c. So we're done with that part. So now we'll do u substitution. So we'll set u equal to 0.5x plus 4, and du will be 0.5 dx. And this integral will become 1 over the square root of u, all times, well, we have to solve for dx here, so let's write dx is 2 times du, so all times 2 du. And then we have the plus 2.8x plus c already from above. All right, let's rewrite this. Integral here as u to the negative 1/2 times 2. And then we can antiderive it using the reverse power rule. So we add 1 to the power, we get u to the 1/2, divide by that 1/2, and then include the part that we've already antiderived. Back substituting that 0.5x plus 4 for u. And then dealing with the coefficients here, we have 2 divided by half, that's 4. We get the following function. This is our revenue function. And now we need to find c. We need to find this c using the fact that r of 0 is 0. So if we put 0 in for x, we should get out 0. And the first part, the first term here is going to be 8. 4 times the square root of 4 is 8, plus c. That has to be 0, so c has to be negative 8. And then this gives us our revenue function in its entirety. R of x is 4 times 0.5x plus 4 to the 1/2 plus 2.8x minus 8. Let's do another example. So in this example, we're going to be giving the average cost rate of change. So the average cost of a product changes at the rate c bar prime is negative 6 over x squared plus 1 over 6. Okay, and the average cost of 6 units is $10. So what this means is c bar of 6 equals 10. All right, and we want to find c bar of x. All right, so the average cost is going to be the integral of the rate of change of the average cost. In other words, the average cost is the antiderivative of the derivative of the average cost. The antiderivative undoes the derivative. And if we just plug in our rate of change here, we'll get the integral of negative 6 over x squared plus 1 over 6, or the integral of negative 6x to the negative 2 plus 1/6. Using the reverse power rule, this will be negative 6x to the negative 1 all over negative 1 plus 1/6 x plus c. If we clean this up a little bit, we'll get 6 over x plus x over 6 plus c. And now we can use our initial condition. Our c bar of 6 is 10. So the left-hand side is 10 when x is 6. We can use this to find c. So we'll get 10 equals 2 plus c, or c equals 8. And so c bar of x is 6 over x plus x over 6 plus 8. We took a rate, we started with a rate, and we found the amount, the average cost. All right, I hope you found this video useful.